Good morning, everybody. This is a live recap on the major winter storm that is currently impacting portions of the central and northern plains, but is about to shift toward an Alberta on steroids to more of a coastal storm with impacts just a little bit inland away from that coast. Winter storm watches are in effect across a large section of the central and eastern U.S., and there you can see the latest GFS model taking that coastal low from south to north through the eastern U.S. There are still those model discrepancies, especially in the southern Appalachians, with regard to the thermodynamics differences between the GFS and the European model in upstate South Carolina to northeastern Georgia and the North Carolina Piedmont. The European model still shows mainly a snow event, even up against the Blue Ridge Escarpment in the adjacent Piedmont area, down to about 1,000 feet in elevation and below, even double-digit snowfall totals down into Greenville, South Carolina, where the new GFS is still showing mainly an ice event just to the southeast of that highest terrain along that Blue Ridge Escarpment that's up there about 2,000 to 3,000 feet just to the southeast of that terrain across the Carolina Piedmont. It's showing more of an icing event there. You can see it in the pink as that evolves, and there's probably going to be a tornado outbreak over the open ocean as well. I expect a tornado outbreak over the Gulf Stream, which really is irrelevant at this point. But right now, we do have the Alberta Clipper that is diving off to the southeast. You can see that area in purple. That's the highest probability for greater than 4 inches of snow. And right now, we still have decent snow. Looks a little bit anemic, this swath of snow, but you do have some of these embedded heavier bands within this Alberta Clipper that's diving off to the southeast. It just hasn't quite tapped in to the Gulf of Mexico yet, so that's why it looks a little bit moisture starved. But once it gets off to the south and then the south central U.S. and it's able to tap into that Gulf of Mexico, that's why there's going to be a lot more snow for locations like Nashville, Tennessee, down into the East Coast. So let's take a look at the latest evolution of the GFS model. This is the official 12Z GFS that is hot off the press. And I am going to be activating storm chase mode. So I'm going to be flying into Greenville, Spartanburg today. That is actually where the Dominator 4 is located. And so my plan is to meet up with the Dominator 4, meet up with Gizmo, cover this storm as it moves through the Western Carolinas. A pretty significant storm system, that is for sure. So let's take a look now at the forecast models. And this is the latest GFS that we are seeing here. Get rid of the loop. So this shows that coastal storm off the eastern U.S. and we kind of have a double ejection. You've got this 974 millibar low here out over the open Atlantic. That's over the open Gulf Stream. It's going to settle offshore of Nova Scotia by tomorrow morning, by Saturday morning, and then eventually it ejects, making way for the next system. You've got a 1042 high over southern Ontario. You have cyclogenesis that's happening over the southern high plains, and then that swath of snow that looks a little bit anemic right now, but eventually that thing is going to tap into the Gulf of Mexico and be supercharged. This is by tomorrow afternoon. Finally gets that fetch into the Gulf of Mexico. That moisture feed, you get heavy snow, southeastern Missouri, possibly even into the Ozarks of northern Arkansas, southern Illinois as well. And that southern stream system passes off to the east, bringing in that cold air. Look at that 1038 high, blocking high pressure up into southeastern Canada. And we could go 12 hours. This is Saturday evening. GFS showing a rain event that's eventually going to change over to snow as that upper level low moves overhead, bringing in that cold air. You can see the cold air coming in behind this system. I wonder if there's going to be some supercells and some tornadoes that are able to evolve from the eastern Gulf of Mexico into northwestern Florida, even southern Georgia. But then by Saturday night, this is midnight Saturday, snow beginning across the southern Appalachians, western North Carolina, back into the higher terrain of northeastern Georgia. And eventually it starts off as rain across upstate South Carolina. And then look at this system start to intensify as it begins to interact with that temperature gradient along the western Gulf Stream. You've also got this blocking high cold air waiting across the northeastern U.S. It does look like it's going to be a rain event. New York City, southern New England, the heaviest snowfall totals are going to be just inland a little bit. Look at the Carolina Piedmont getting that big ice storm. snow as well by this time. This is basically Sunday at about noon to 1 p.m. to early afternoon. Wraparound snows impacting upstate South Carolina. Even some snow showers down into the Atlanta area by this time as that cold air wrapping around this powerful mid-latitude cyclone. And it starts to head up toward New York City, hugging the coastline. This track of the surface low right along the coastline is not ideal for snow across the northeastern U.S., at least along the immediate coastline. Interior, of course, in the mountain regions, very good for very heavy snow. But it looks like that warm air, that warm conveyor belt pumps into New York, changing that snow over to a rain up into southern New York as well, into southern New England. Boston as well changes over to that rain. And this is just a new 12Z operational GFS. There still is some uncertainty with this system, but with this track right along the immediate coastline, it does appear that it's going to change southern New England and southern New York over to a rain. But look at that heavy snow blasting southern New Hampshire, southeastern Maine, southern Vermont, the mountains there of western Massachusetts out near Springfield. Looks like you're going to be an absolute winner for this system with this track. And then it's going to sit there and spin out over New England and then meander off to the north. Heavy snow showers along the northwestern slopes. A little bit of some lake effect as well develops off in its wake. So let's take a look now at the snow maps. This is what everybody's waiting for. And I want to talk about that continued discrepancy between the European model and the GFS, the new GFS. And it just has to do with those low-level thermodynamics. So there is the snow map. We could cut to the chase for the northeastern U.S. And that heaviest snow is going to be over the interior, over the mountain regions, the Berkshires, interior New England. Looks like New Hampshire could get blasted, of course, Mount Washington, and as well as those mountains of western Virginia, the adjacent foothills. Bit of a lake effect response as well. So let's take a look at a different off to the southeastern U.S. And so my plan to cover this, as I mentioned, is to head into Greenville, Spartanburg, and I'm going to work the snow event over the mountains of western North Carolina. I'm also going to work the ice section of this storm because I know that that's going to be substantial. So here you can see the latest snow map, and look at that tight gradient right along that escarpment. Right along that highest terrain, locations like Pretty Place, along that North Carolina, South Carolina border, double-digit snowfall, pushing 2 feet over some of the higher terrain of western North Carolina. But that sharp gradient along the South Carolina, North Carolina border, just to the southeast of that gradient, that is going to be dominated by ice. And I'll show you the GFS. We still have that discrepancy between the GFS model and the European model, zooming way in on that tight gradient. You can see about 3 to 4 inches of snow in Greenville and a lot of ice. So even though you do have that sharp gradient, you're going to pay the price of the lack of snow with maybe over an inch of ice right along the immediate Piedmont, but big time snow then across the mountains of North Carolina. So now let's take a look at the European model. This is the 6Z European, and this is still holding on to a colder profile for snowfall along the immediate Carolina Piedmont. Upstate South Carolina, Greenville has double-digit snowfall totals a foot across the Appalachians of western North Carolina. Carolina Piedmont, several inches of snow. And also look at Nashville there, getting in on about an 8 to 10 inch type of a snowfall. Some of the higher terrain to the southwest of Nashville could get even more. Some of those locations that we were already chasing supercells on December 29 and January 1st could get even close to a foot once that system starts to tap into that Gulf of Mexico moisture off to the south. And then look at that snow band. I want to make sure I'm still live here. Oh, good. Still live, showing these snow maps. So the European model has more in the way of snowfall, and now we're going to look at why there's that difference in the low-level thermodynamics. And here is the GFS. Probably going to see that much snowfall. You're probably going to see 1 to 2 feet in the mountains of western North Carolina, especially those higher balds up there, Beech Mountain. Maybe I could go to the top of a bald with my skis, hike up there and cover the snow from a very high elevation, or I could cover the ice right along the immediate southeastern, just to the southeast of the escarpment. I was looking at some of those forecast soundings as the event is taking place. And boy, that layer that is just above freezing, just above the ground, is pretty minuscule and modest. And so I think that dynamical cooling is going to happen, and it's going to bring that warm nose just a little bit below freezing. But I'm going to show you the different soundings between the two. This is the GFS model. Begins everything off as rain across upstate South Carolina, but heavy snow across the mountains, far northeastern Georgia, western North Carolina. Ice begins across the Carolina Piedmont. And you can pick a sounding right there near the Greenville area, right near my mom's place. And it shows it just above freezing. That is the freezing line, that blue line, barely above freezing at the low levels. But you've got a lot of cold temperatures above. You're not seeing much in the way of a warm nose. Those surface winds in easterly direction, not just above the ground. You do have that warm advection. But boy, are the temperatures right where that warm advection is maximized, between about 1 and 3 kilometers. Looks to me like that there's not much of a warm nose just above the surface, and that with heavy precipitation, you should be able to bring down that cold air just above the surface and result in a changeover. So this is the upstate South Carolina area. Let's take a look just to the southeast of the highest terrain, where you have an elevation of about 1,000 feet. And there's your development of that warm nose. As that surface cyclone intensifies, southerly winds just above that relatively shallow sub-freezing layer. Your surface temperatures cool with time as it pulls in that colder air to the east of the Appalachians from the northeast. You've got that monster high over the northeastern U.S., very cold temperatures up there. But here's that little bit of a warm nose that is indicated by the GFS across upstate South Carolina that would result in a major icing event just southeast of the escarpment. There's your low across northern Georgia. So let's hop on over to the European model. So the European model seems to have a weaker low across northern Georgia. The GFS has a 998, a stronger low, more warm advection, a stronger warm nose as well. Whereas the European model has a slightly weaker surface low, a little bit deeper of a cold air mass, a lot more of an icing event, and a bigger snow event as well. And there you can see, look at the colder temperatures at the surface. The European model seems to have a better handle on the very cold surface temperatures that are going to be available to this storm, especially as you get that surface low. You get those northeasterlies to the east of the Appalachians pulling down that cold air. You've got like a 1030 high. Getting some decent snow here in the Colorado foothills right now. There are no winter weather alerts, just trace amount of snow is expected here, but I am seeing some decent snow here in the Colorado foothills at about 7,200 feet as well here to the west of Denver. But there's that warm nose. You can see the freezing line. So it does look like there is going to be an icing event at the very least across the Carolina Piedmont, and it looks like a pretty substantial icing event as well. Look at that thing, warm conveyor belt through eastern Carolina. It does look like it's a slightly further west track, which should keep the winter weather hugging the Carolina Piedmont a little bit closer to the Appalachians, a little further west. Raleigh, definitely going to be more of an all-rain type of an event. And then you get the wraparound snow showers across the southern Appalachians. This is a Sunday evening at about 7 p.m. Still a lot of model discrepancies, though. Definitely the surface temperatures are a lot different between the two. And I tend to believe the European model a little bit for these winter storms, just a little bit more trusted. Let's take a look at the ice accumulation map here. Total freezing rain accumulation. And this is nasty. The European model is showing a very impactful ice storm, a little bit colder of a run. This is the 6C European model. But look at that icing. It definitely has colder air in place before this system arrives. across the Carolina Piedmont. That's going to result in mass power outages, certainly, across the Carolina Piedmont, central South Carolina. And that's because of that warm nose getting lifted up and over that sub-freezing air. That is nasty right there. Let's see how that compares to the GFS model. Not as much. And a lot of it is due to the availability of that cold air for the system that precedes that system. In my opinion, cold air, even shallow cold air, especially that's associated with a monster high like that, sometimes can be difficult for these models to resolve just how stubborn that cold air is going to be when you have a surface wave that moves along that location. And so I just think that the GFS may be underestimating the stubbornness of that cold air that's going to be available at the surface. The 3-kilometer NAM seems to be more robust with that icing as well off to the southeast, a little bit more snow. I know you're not supposed to use the convective allowing models for this, but we're going to look at them anyway. Let's go back toward the regular NAM. Regular NAM has eastern Tennessee being in a bullseye, a nice stripe of snow. Knoxville getting hammered as well. This is the new NAM. Also has western North Carolina getting blasted. But it really is reckless to be using a NAM model like this for these. We'll just stick to the GFS and the European model. This is the new 12Z GFS. Just having the mountains of western North Carolina being the breadwinner for those snowfall totals, but a big icing event as well. But I do believe that the European model has a better handle on that cold air at the low levels, the depth of the cold air, the heavy precipitation and dynamical cooling, definitely helping to encourage more of a snow event. So I think that this is a decent snow map here. 6Z European model. It'll be interesting to see what the 12Z run has if it wavers back toward the GFS for those low-level thermodynamics. So there is your icing. There is your freezing rain accumulation by the European model. And it looks like more of an interior event for the northeastern U.S. So my plan overall is to head to upstate South Carolina to cover this. I'll be streaming live this entire event as it's evolving. Do want to take a look at some of these snow maps as well for the Central Plains for this Clipper system. This is the 6Z European. Shows some double-digit snowfall totals, about 6 to 10 inches. That will include Des Moines area, just to the southwest of Des Moines. Unfortunately, Omaha, you're going to miss out on the heavier snow. It's going to be off to your east, definitely an Iowa event. But those totals ramp up as it gets a little closer to Iowa. And then eventually that system starts to infuse that Gulf of Mexico moisture. And that's when Tennessee is going to get in on the action. But could get some decent banding in Iowa, central, southwestern Iowa into northern Missouri. Definitely could be. I know that you're used to the snow. And then look at the European model picking up on these big time totals across Tennessee as that system rounds the bend, digs down to its lowest latitude, and starts to infuse that Gulf of Mexico moisture. So I do also want to look at the severe weather potential along the coastline. Anytime you get a coastal system like this, there is a threat of some surface-based instability being associated with the strong low-level jet. So let's take a look at the severe weather potential along the immediate coastline. Let me change my region here as well. So there's our low, and we're going to be watching for the presence of surface-based instability just meandering onto the coastline. And we'll look at these dew points. There are some 60 dew points right along the immediate coastline, that moisture wrapping into eastern Georgia. Any cape, any surface-based instability beneath that low-level jet will have the potential, maybe even getting a little tornado or two, maybe some convection. We'll look at the convective allowing model, look at the 3-kilometer NAM. Let's look at the HRRR here. 12C HRRR. Just using it to assess the presence of any surface-based instability. May not be able to go out far enough. This would probably be Sunday night. This would be a Sunday evening, overnight Sunday type of a threat. Just as that surface low is passing through eastern North Carolina. But you can see these 60s dew points barely meandering onshore. Let's take a look at a sounding at Cape Hatteras. And it is supportive, marginally supportive of a tornado. Very favorable hodograph, as you can see. So the kinematics are definitely supportive of a supercell or two. And you could definitely see some surface-based instability available within at least this sounding, 64 over 63. A little bit of cape in the mid and low levels. Not the greatest in terms of lapse rates, of course, but look at that hodograph. Let me make sure you can see the hodograph and that my head is not in the way. So I could easily see a skinny squall line blasting through eastern North Carolina and maybe some surface-based instability coming on ashore. Those storm motions would be due north, north-northwest at about 50, 55 knots. A lot of easterlies in the low-level flow as well. Look at that low-level jet, that moist, warm conveyor belt there that's streaming into the system. Show you that in the models here. Look at that low-level jet. So it's just a strong surface low, just like you would chase with a big tornado event, but except this is a coastal low ramping up, pulling in that moisture feed from the Gulf of Mexico. But that's a big low-level jet, and it is going to be associated with some low-level wind shear as well. Look at that across eastern North Carolina. Some of those values in excess of 200. Looking at EHIs. This is at 3Z Sunday evening, so this is late evening, 9, 10, 11 p.m. out here as you get that instability axis feeding up toward eastern Carolina. Maybe a little bit of surface-based instability coming ashore there across coastal Carolina. Not a bad hodograph. It is a little bit skinny compared to that other hodograph that we were observing. Just a little bit skinny of a hodograph, but you could not as favorable. But across eastern North Carolina, as that surface low passes just to the west, you get a lot more of those easterly flows within that easterly component to the low-level winds, to the low-level jet. But there is a little bit of surface-based instability that comes ashore on Sunday late afternoon across eastern Carolina, but it really comes ashore Sunday evening across eastern Carolina and the Outer Banks. Let's go toward midnight Sunday night, and then that instability moves offshore. So there's a narrow window late evening, Sunday evening, where I wouldn't be surprised to see a skinny squall line moving through that area and maybe even an isolated tornado threat. There's that skinny squall line. Let's go just a little bit earlier in time. So a possible skinny squall line that'll march through eastern North Carolina. You're looking at the NAM here. Maybe some surface-based instability comes in. Differences, though, in the position of the surface low and the timing of that convective line. GFS model has it a little bit earlier. Sunday evening, late afternoon. Looks like a late afternoon event across eastern Carolina, maybe an evening event, depending on if you believe the NAM or the GFS. Still incredible, though, these differences in timing. It just shows you how complex an evolution of these, the evolution of these coastal storms can be. These powerful mid-latitude cyclones. You have an Alberta Clipper that's diving off to the southeast. You have another coastal storm that's ejecting off the Canadian Maritimes. You have another high pressure that's building in across the northeast. There's your 12Z GFS surface low position Monday morning. Look at this weird convective feedbacks within the GFS model for the surface low. Look at that. It's got like a triple-headed, three-headed monster for surface lows. I do believe that the GFS is just picking up on this surface low and maybe some diabatic heating, massive diabatic heating release, helping to bomb out that surface low. And then you look more at the European model, and it's a lot more consolidated as that 12Z model's coming in. Well, it looks like the European model shows that as well. It shows the main parent surface low. That will occlude a bit, almost like a cycling tornado, and then new mesolows will form further southeast, a little closer to that front. And look at those supercell storms over the open Gulf Stream, over the open North Atlantic, south of New England. Just incredible to see this evolution happen right before our eyes. And look at that. Interestingly, the European model also has these mesolows forming and kind of a cycling of that surface low reflection off to the southeast, a little bit closer to that diabatic heating max. Excuse me, latent heat release. Wow. Yeah, look at that conveyor belt of supercell storms. And this is transporting heat. There's a runaway condensation happening here, latent heat release as well. So that's why you get the ridging aloft out ahead of these storm systems. Definitely a warm conveyor belt, changing everything over to more of an all-rain event across southern New England. And look at these different mesolows forming. So it really ramps up and intensifies, but brings that warm air into southern New England. But the 12Z European model is coming in hot right now. Still has that snow bias, that relatively more accurate handle of the colder temperatures to the east of the Appalachians. The new European model is coming in, and there are still these discrepancies with the GFS. The GFS does a pretty good job at handling these surface temperatures relatively with these wintertime severe weather events, but it seems to have a bit of a warm bias here and with the low-level thermodynamics. Look at that with the 12Z GFS compared to the 12Z European model precipitation type. Wow, what a difference. Let's see what it has as the surface low reflection. Roughly the same. So it's not related to, it's definitely related to handling of the low-level temperatures. So you are getting a live look at the European model as it's coming out. It does seem to shift everything over to ice in the Greenville area as well, but a lot of cold air, that sub-freezing air, definitely extends well to the southeast of the Appalachians across the low country here of South Carolina. This is as of Sunday morning at 12Z. So you're waking up Sunday morning, probably going to have widespread power outages upstate South Carolina and the adjacent Carolina Piedmont. It is looking like more of an icing event here across upstate South Carolina and up toward the Charlotte area. But boy, dominating snowfall across the mountains of North Carolina. Be a fun place to cover this event. Maybe up to 2 feet of snow over the higher elevations of western North Carolina, up into the mountains of western Virginia as well. So thank you everybody for tuning in to this weather report. I'm going to be getting on a flight here shortly and blasting off to Greenville, meeting up with Dominator 4 to intercept this storm system. Let me pull this north a little bit so that you can see what the new European model is showing. Definitely showing that icing upstate South Carolina, up across the Carolina Piedmont. But it is showing colder temperatures at the surface. Not really any much in the way of an all rain event at all. Looks like it's going to begin as little bit of rain, and then it'll change over. So this is Saturday evening, 7 p.m. Begins as a little bit of rain, and then you're going to pull that cold air down from east of the Appalachians and quickly become snow. Dynamical cooling here across upstate South Carolina. But then as that surface low intensifies and that low-level jet brings that warm nose up and over those cold surface temperatures, then it's going to change everything over to more of an icing event. Look at that. Peak low-level jet also. Look at that low-level jet there to the east of that low. Just a little bit of an east-southeasterly component, bringing that warm nose up and over that environment. There's your warm nose. Really, the green is your zero line at 850. So it certainly stays below freezing across the escarpment, but then just to the southeast, you get the nosing in of that warm nose over top of those sub-freezing surface temperatures. Likely going to change everything over to freezing rain there, and then it shifts on over to snow, the wraparound on Sunday afternoon. So it does look like a pretty impactful event, everybody. I will be covering it live. Thank you for tuning in to this long weather report here. Basically just as I'm browsing through the models, coming up with my storm chasing plan. But thank you for tuning into my weather report this morning. And I look forward to sharing with you my live coverage of this winter storm starting tomorrow evening, Saturday evening. Never stop chasing.